Hi everyone, and welcome back to Grade 12 Maths with Mr. Simons, where we make maths simple and get you exam ready, right? In today's lesson, looking at November 2024, question 11, looking at tangent and a similarity problem, right? More specifically, this problem has two circles and two tangents from the same point. So we're testing tangents from the same point as well as tan chord, no tan perpendicular to radius. Right, but let's look at the problem. It's the last question. It was asked under Euclidean geometry, and this is the one that caught out many learners. So I hope I'm able to do justice to the problem and get you to understand. Right, so let's first look at the problem. Right, so if we look question 11, tangent and similarity problems, and they say in the diagram A, B, G, and F lie on the largest circle. So they're the largest circle. A smaller circle is drawn to touch the large circle internally at A. So the smaller circle and larger circle make contact at A. EA is a common tangent, so EA is a tangent for the small circle, but it's a tangent for the bigger circle as well. Right? To both circles. EBCF is a tangent to the smaller circle at C, so EBF, smaller circle, it's a tangent there at C. Right, and AC is produced to G. AF cuts a smaller circle at T. Alright, so generally with these problems, first one they say if EHE equal X, so now they haven't given us any values to say 20 degrees or etc. So technically we're solving a rider. Determine what reasons 4 other angles equal to X. So EAG, A1 and 2 there, according to them is X. It's given as X. Right, and then we have to find 4 other angles equal to X. Once we're done with that, we're going to use whatever we found there generally to prove that AG times AD equal AC times AF. And then they want us to prove similarity there. So that's why you see I said similarity problem for 4 marks. And then using the similarity, we're going to prove or solve a ratio for another 6. So that's a 20 mark straight that was asked last year in November 2024. All right, so let's go to the first problem. And I say, I hope you follow. So I say, pause, write down what I've written if you want to think, or listen first. It's entirely up to you, or you can attempt it yourself. All right, so 11.1, if EAG equal X, EAG equal X, I've drawn, determined with the reasons 4 other angles equal to X for 6 marks. All right, so I find that even when I work here at my tuition center, that it's more, or learners find it easier when we include color. All right, so first thing I've done, I've drawn a tangent EA, the common tangent for the smaller and bigger circle in red, and EC, the other tangent, also in red. All right, then we have a tangent, we draw an angle from a tangent to a chord inside a circle. That chord must form a triangle that touches all 3 points of the circumference of that circle. So thereby A3 is making contact C2, D1. So we look at that angle between the tangent and the chord, can't equal A3. That's next to it. Can't equal C2 because then it would be alternating angle. So they didn't say this is parallel to that. So it always equal the angle directly opposite it. So there, that whole EAG or EAC, right? That whole one, A1 and 2 equal D1. And my reason would be tan chord. All right, so there, T1 equal EAG equal X, tan chord theorem. So 1 mark for my statement there, 1 mark for my reason. Same applies if we come here by this tangent formed by C1. C1 can't equal C2. C1 can't equal A3. They're not alternating. right? So C1 equals the angle directly opposite in the triangle, which then C1 equal D1, tan chord. So C1 equal D1 equal X, tan chord theorem. 1 mark for statement, 1 mark for reason. Alright, now if you look there, EG, now look at EF. They form a X there, so C1 equals C4. I assume you remember from grade 9, those are called vertically opposite angles, right? So C4 equals C1 equal X, vertically opposite, so therefore C4 they also equal X, right? Then AFG, right? AFG, this angle here, see there, 1, 2, 3, forms a bigger triangle, bigger circle, so this whole angle here can also go to, according to tan chord, it can't equal A3. It can't be alternating with G there, but it equals the whole angle opposite it, which is F. So this angle equals angle F, also tan chord theorem. So 1 mark for this statement. So 2, 4, 5, 6 marks. Right, so I hope you follow. I hope you see how I've done tan chord theorem. Very important that you know it. Tan chord, what angles in the same segment, equal angles, equal sides, or equal sides, equal angles, the corollary of theorem 4, angles in the same segment. These theorems are asked a lot in exam, specifically the ones I mentioned earlier. Right, so hope you follow, hope you understand. Right, now let's look at the second problem. Right. Right, somewhat reason I have this irritation in my throat, but yeah, won't let it deter me. 11.2, they say prove that AG times AD equal AC times AF. So AG times AD must equal AC over AF. Right, now the first things we should note, remember in the previous problem I've proven that T1 and this angle F here are both X. No? So T1 equal AF equal X, that was proven. For those to be equal, you see in gold there, remember grade 9 we taught you the letter F, or fun angles as your teacher called them. So there they form the letter F if I look there. So they are corresponding. So therefore I can say CD is parallel to GF, right? Corresponding angles. Yeah? Right, so the corresponding angles are equal. Or we could have said converse of corresponding angles, right? So DC equal FG. So DC parallel to FG. Alright, so from that triangle there, should see if you've done the proportionality theorem already with your teacher at school. If you haven't, you can go look at one of the prop theorem problems we've done here. Right, but in short, those two are parallel, then I can say AD over TF must equal AC over CG. Right, or I can go long AG, the long side over the short side AC, equal AF, the long side over the short side AD. So there you should pick that up. That's given to you. AG over AC equal AF over AD. Proportionality theorem, DC is parallel to FG. Now if we just cross multiply, AG times AD equals AF times AC. Right, and there we ended up with the statement that we had to prove. So 1 mark for the statement there, that D1 equal AFX proven. Right, 1 mark for the fact that they are parallel. Another mark for, or 2 marks for writing out the sides that are in proportion using prop theorem, and then just cross multiplying, no mark. Right, now let's go to the third problem, which is similarity. Alright, now for 11.3, they say prove the triangle AGF is similar to ABC. 3 lines facing straight up, similarity, meaning the two triangles look the same, but the one is bigger than the other one. That's basically what similarity means. So if I say in triangle AGF, which is the bigger triangle there, and triangle ABC, which is that smaller triangle. They have drawn them separately for you. Right? Now, there you see I started off and I said angle G from here equal angle P2. So this angle G equal angle P2 there. And my reason, angles in the same segment. So you see there the two lines. If I go back with G stops, the angle G is subtended by that chord AF. Né? So AF is the one that basically G is opposite to. Né? Alright, so it's subtended by AF. It's resting on that line. If we go back with B2 goes to A and F, so therefore AF is also subtending B2. They both in the bigger circle touching the circumference, so therefore B2 equal angle G. And we say angles in the same segment, right? So there, angles in same segment, so G equal B2, statement and reason. Alright? Then we have AFG. So AFG forms angle F equal angle C1. Alright, so remember we had C1 equal T1 tan chord, and we had D1 equal angle F also based off that angle tan chord. Right, so it was proven in 11.1, so therefore that C1 and F are both X. That was proven. Right, so all we left with is the E2 and the E3. Those two we don't even need to work out. Because if this is 40 and that is 60, then this would be 40 and that is 60. 40 plus 60, 100. 40 plus 60, 100. So 100 and 100, the triangle can only add up to 180. So if this is 100 and that's 100, then that must be 80 and that must be 80. Alright, so you can say E3 equal E2, sum of angles in a triangle, or I can say third angle. Past we also said remaining angle. So therefore, there now we have three angles that are the same. Therefore, triangle AGF is similar to triangle ABC. And my reason is angle, angle, angle. Right? Angle, angle, angle. Right? So 1 mark for statement and reason there. Another one for the statement because it's proven already. And there 1 mark for the statement, 4 marks. Alright? Now let's go to the next or last problem. Right, now they say we must prove that GF squared equal BC times FC times AF over AD. Right, so remember we proved that in the previous problem, triangle AGF is similar to triangle ABC. So GF, the last two letters there, over the last two here BC must equal first and last over first and last. Should equal first two over first two. That's the proportion created. So GF over BC, so GF over BC equal AF over AC. Alright? Now if I cross multiply and I make GF, you see they have GF squared. So I say GF would then equal AF times BC over AC. Alright? But triangle ACD, so ACD there, right, is similar to triangle FGC. Alright? So FGC, see the FGC, they are similar. Again, my reason would be angle, angle, angle. Right? So from there I can say AC over GF, AC first two there, must equal first and last over first and last, AD over FC. Right? So from there AC would then equal AD times GF over FC. Right? So yeah, instead of using AC now, I'm going to use the statement of AC and put it in the place of AC. Right? So GF, which equal BC times AF over AC. GF would equal BC times AF. divided by this new version of what AC is, ADGF FC. Right, if I change division to multiplication, FC and AD times GF change positions, right? So we use the reciprocal or we invert the fraction, right? So that becomes FC over AD times GF. So therefore, GF squared, right? So there we have BC times AF times FC over AD times GF, but GF times GF becomes GF squared. So BC times AF times FC is left on the top over AD. That GF goes across and therefore it becomes GF squared. So if we look here in ACD we had A3, C2, D1 and FGC, right? We can go a long process, but in short, yeah, angle to prove that they are similar. Right? So I hope you follow the problem. And this is very complex. Actually not. It's just concept of proving similarity and understanding that similarity, you're going to always use this ratio. First two letters over first two letters must equal last two letters over last two letters must equal first and last over first and last. And that's how we write out the ratio. And then from there, we'll just choose which side we would make the subject of the formula. Hope you found the lesson useful. If you found this helpful, hit like and subscribe so that you don't miss out on our next video lessons that's coming up. As I said, I'll be doing a series of exam questions on Euclidean and many other topics, and I hope this truly helps you. I love teaching maths. I love helping learners. I even enjoy teaching. Okay, actually my first love is physics, but yeah, anything to help and make you better. Right? God bless. Bye.